Hello, in this lecture we'll find out the area of the green triangle. In the drawing we have square ABCD. We know that one side of square ABCD equals to 4 units. Inside this square we have a circle, this circle, and the radius of this circle is equal to 1 unit, and we want to find out the area of this green triangle. So first of all, I will present to you a new rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So I will read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have a circle, well, this circle, and we have tangent AB, this tangent AB is tangent to this circle at this point. We define this point as point M. Point M is the point of tangency of tangent AB with this circle, and we define the center of this circle as point O. Then we draw radius from point O to point M. So this is the radius of the circle, it equals to R. So as you can see, this radius, the radius OM, it is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with the circle. Therefore, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? So whenever you have a radius, like in this drawing, that is drawn to the point of tangency, then the tangent will be perpendicular to this radius. In this case, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tangency. So this radius OM, it is drawn to the point of tendency, therefore the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle also will be equal to 90 degrees. Okay, that is the minimum rule number 1. We can implement rule number 1 in our drawing, because in our drawing we will define the center of this circle as point O, and we define the point of tendency of tangent AD with this circle as point M. M is the point of tendency of tangent AD with this circle. So, and OM is the radius of this circle that equals to 1. It is given us in the question. So here we have this radius, the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AD with this circle. Therefore, according to rule number 1, the tangent AD will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? And you also know that all four sides inside all four angles inside the square are right angles. Therefore, this angle that is inside square ABCD will be equal to 90 degrees. It is a right angle. And we will define the point of tendency of tangent AB with this circle as point N. Then we join together points O and N by a straight line. ON is the radius of this circle, that is to say it equals to 1 unit. ON is the radius of this circle because of the fact that line segment ON starts from the center of this circle, that is to say from point O, and that's at the point Z, and then that's point N, that is a point on the circle itself. Therefore, ON is the radius of this circle. And as you can see, point N is the point of tendency. Here, point N is the point of tendency of tangent AB with this circle. And we have this radius ON, it is drawn to the point of tendency, that is to say, it is drawn to point N, that is the point of tendency of tangent AB with this circle. Therefore, according to rule number 1, whenever we have a radius that is drawn to the point of tendency, like in this drawing, then the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be equal also to 90 degrees. Okay? We define the point of tendency of tangent CA with this circle as point K. Then we will join points O and K together by a straight line. Actually, line segment KO is the radius of this circle because of the fact that line segment KO starts from the center of the circle, that is to say from point O, and that's at point K, that is a point of the circle itself. Therefore, OK is defined as the radius of this circle. So we have here this radius that is drawn to the point of tendency, that is to say it is drawn to point K, that is the point of tendency of tangent EC with this circle. Therefore, whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? In the next step, I will present to you a new rule. Rule number 2. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. Write it down. The sum of the angles in any quadrilateral is equal to 360 degrees. So I will read rule number 2 again. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. So we will focus on this small quadrilateral MOAN. According to rule number 2, the sum of quadrilateral MOAN angles must be equal to 360 degrees. So we will focus on quadrilateral MOAN. According to rule number 2, the sum of its angles must be equal to 360 degrees, which angles quadrilateral MOAN has. It actually has 3 right angles, 1, 2, 3, and the sum of 3 right angles is equal to 90 times 3 is 270 degrees, so the sum of those 3 angles is equal to 270 degrees, plus the size of the fourth angle, the size of this angle that we define as angle X. So the sum of those 4 angles must be equal to 360 degrees according to rule number 2. I'll repeat again. In quadrilateral MOAN, the sum of its angles must be equal to 360 degrees according to rule number 2, which angles quadrilateral MOAN has, yet it has 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle. In total, those 4 angles must be equal to 360 degrees. We will subtract 270 degrees from this equality, and we will get that angle X equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle X is a right angle, it equals to 90 degrees. Here we can substitute X by right angle, because X equals to 90 degrees. So actually, as you can see from the drawing, you can see that all 4 angles of quadrilateral MOAN are right angles, And we also have rule number 3. According to rule number 3, if a quadrilateral has 4 right angles, then it must be if a quadrilateral has 4 right angles, then it must be at least a rectangle if not a square. So I will read rule number 3 again. According to rule number 3, if a quadrilateral has 4 right angles, then it must be at least a rectangle, if not a square. And our quadrilateral MOAN, this quadrilateral has 4 right angles, therefore we will relate to quadrilateral MOAN as a rectangle because it has 4 right angles, so according to rule number 3, it must be at least a rectangle. So we will relate to quadrilateral MOAN as a rectangle. We will relate to quadrilateral MOAN as a rectangle. Okay, we will relate to quadrilateral MOAN as a rectangle, and we also have rule number 4. According to rule number 4, the opposite sides of a rectangle are equal to each other. according to rule number 4, the opposite sides of a rectangle are equal to each other. So we know that quadrilateral MOAN is a rectangle. Therefore, its opposite sides are equal to each other, according to rule number 4. So here we will get that MO is equal to AN according to rule number 4. MO is equal to AN according to rule number 4. It is given us in the question that MO equals to 1, so we can write here that MO equals to 1. And from this equality, we will conclude that AN also equals to 1. So we can write here that AN equals to 1. Likewise, according to rule number 4, MA also equals to ON. According to rule number 4, MO equals to AN. But we have already found out that ON equals to 1. ON equals to 1. And from this equality, we will conclude that MA also equals to 1. MA equals to 1. So we found out that MA equals to 1. Actually, we found that all sides of quadrilateral MOAN are equal to each other and they are all equal to 1 unit. And we also found that all 4 angles of quadrilateral MOAN are right angles. And so we also have rule number 5. According to rule number 5, if a quadrilateral has 4 right angles and 4 equal sides, it must be a square. If a quadrilateral has 4 equal sides and 4 right angles, then it must be a square. It must be a square. I will read rule number 5 again. According to rule number 5, if a quadrilateral has 4 equal sides and 4 right angles, then it must be a square. So quadrilateral, our quadrilateral MOAN, this quadrilateral has 4 equal sides and also 4 right angles, therefore quadrilateral MOAN is a square according to rule number 5. Quadrilateral MOAN is a square according to rule number 5. Repeat, quadrilateral MOAN is a square because it has 4 equal sides and 4 right angles, therefore according to rule number 5, it must be a square. And we also have rule number 6. According to rule number 6, the diagonals of a square bisects the angle of the square into 45 degrees angles. So I read rule number 6 again. According to rule number 6, the diagonals of a square bisects the angles of the square into 45 degrees angles. So if we focus on our square, the small square MOAN, then according to rule number 6, the diagonal OA bisects this angle that is a right angle in two angles, that each of them are equal to 45 degrees. So the diagonal OA, this diagonal of square MOAN, bisects this angle BAB, into two angles that each of them is equal to 45 degrees. So according to rule number 6, this angle equals to 45 degrees, and this angle also will be equal to 45 degrees. So you can say that the angle OAN is equal to 45 degrees, this angle, according to rule number 6. But it doesn't matter at all if we relate to this angle that actually equals to 45 degrees as angle OAN, or if we call this angle as angle OAB. It will not change the angle itself, it will not change the size of the angle, it still will remain 45 degrees. Why? Because points B and N and also A are located on the same straight line. So we will relate to this angle that equals to 45 degrees as angle OAB. Okay? Actually, even if we extend the side of AB more, and we will define a new point as point S, we can call this angle as angle OAS, and it will still be 45 degrees. Okay? So according to rule number 6, angle OAB equals to 45 degrees. Okay, we found out that angle OAB equals to 45 degrees according to rule number 6. Likewise, if we focus on square ABCD, the Greek square, then according to rule number 6, the diagonal CA bisects the same angle into two angles that each of them will be equal to 45 degrees. Okay, so the diagonal CA this diagonal CA of square ABCD creates angle CAB that also equals to 45 degrees according to rule number 6. Angle CAB also equals to 45 degrees according to rule number 6. So actually, those two angles, angle OAB equals to 45 degrees and angle CAB also equals to 45 degrees. So we can conclude from this that angle OAB equals to angle CAB. Okay, angle OAB equals to angle CAB, or angle CAB Okay, angle CAB equals to angle OAB. Angle CAB equals to angle OAB. From the fact that angle CAB equals to angle OAB, we will conclude that the diagonal CA of square ABCD passes through point O. Okay, we will conclude that the diagonal CA of square ABCD passes through point O. I will repeat again. From the fact that angle CAB equals to angle OAB, we will conclude that the diagonal CA of square ABCD passes from point O. Okay, so actually, as you can see from the drawing, diagonal CA must pass from point O. Otherwise, if we assume that diagonal CA doesn't pass from point O, then angle CAB will never be equal to angle OAB. And because of the fact that angle CAB indeed equals to angle OAB, we will conclude that the diagonal CA must pass from point O. Okay? In the next step, I will present to you rule number 7. According to rule number 7, the length of a diagonal of a square is equal to square root of 2 multiplied by the length of the squares by the length of the square's side. I will read rule number 7 again. According to rule number 7, the length of a diagonal of a square is equal to square root of 2 multiplied by the length of the square's side. So what is the meaning of rule number 7? The meaning of rule number 7 is that if you have square ABCD, so this is square ABCD, And we know that the length of one side of square ABCD equals to S units, therefore all the other sides, the length of all the other sides will be also equal to S units. Then if we know that the length of one side of square ABCD equals to S units, then the length of its diagonals, that is to say the length of diagonal DB and diagonal AC, will be equal to square root of 2 times S units. Okay? This is according to rule number 7. If we know that the length of one side of square ABCD equals to S units, then the length of its diagonal DB or AC, will be equal to square root of 2 times S units. Okay? We can implement rule number 7 in our drawing. We will calculate the length of diagonal OA, or in square MOAN, in square MOAN, the length of diagonal OA will be equal, according to rule number 7, it will be equal to the length of one side of square MOAN, that is 1 unit, times square root of 2. 1 times square root of 2 equals to square root of 2. So we actually found out that the length of diagonal OA equals to square root of 2 units. So we can write here that OA equals to square root of 2 units in its length. Here OA equals to square root of 2 units. We will also calculate the length of diagonal CA of square ABCD. The length of square ABCD, the length of diagonal CA, according to rule number 7, will be equal to the length of square ABCD side, that is actually 4 units, times square root of 2. Will be equal 4 times square root of 2. Okay, we found out that the length of CA is 4 times square root of 2 units, and the length of diagonal OA equals to square root of 2 units. In the next step, we will calculate the value of line segment CO. As you can see from the drawing, CO equals to CA minus AO. CA minus AO equals to CO. CO equals to CA minus OA. Okay, CA minus OA equals to CO. We already found out that CA equals to 4 times square root of 2 units, and OA equals to square root of 2 units. So 4 times square root of 2 units minus 1 times square root of 2 units equals to 3 times square root of 2 units. So CO equals to 3 times square root of 2 units. So we can write here that CO equals to 3 times square root of 2 units. Okay, in the next step, we will focus on the right triangle, triangle COK, or we will focus on the blue right triangle, triangle COK. We will implement the Pythagoras theorem in this blue right triangle, triangle COK. Okay, according to the Pythagoras theorem, in this blue right triangle, triangle COK, According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And the hypotenuse in the blue right triangle COK is CO. Therefore, the square of the hypotenuse is CO squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OK squared plus CK squared. I will repeat again. In the right blue triangle COK, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is CO, therefore the square of the hypotenuse is CO squared, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OK squared plus CK squared. But we have already found out the value of CO. CO equals to 3 times square root of 2 units. Therefore, CO squared will be equal to 3 times square root of 2 units squared. And it equals to OK squared. OK equals to 1. Therefore, OK squared will be equal to 1 squared. 1 squared is 1. Plus CK squared. CK is the missing variable, so we will leave it as it is. In conclusion, we found out that 3 times square root of 2 square equals to 1 plus CK square. 3 times square root of 2 square equals to 9 times 2, so I write it down. 9 times 2 equals to 1 plus CK square. 9 times 2 is 18, I write it down. 18 equals to 1 plus CK square. Okay. We will subtract 1 from equation number 1. 18 minus 1 is 17. We got that 17 equals to CK square. Here we will take a root out of this equation, equation number 1, and we will get that CK equals to square root of 17 units. Okay, we found out the value of CK. CK equals to square root of 17 units. So we can write here that CK equals to square root of 17 units. Okay. In the next step, I will present to you a new rule, rule number 8, the last rule. According to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So I'll read rule number 8 again. According to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 8? The meaning of rule number 8 is that if we have this circle and here point P is an external point of this circle. Why point P is an external point? Because point P is not located inside this circle nor on this circle, but it is located outside of this circle. Therefore point P is defined as an external point of this circle. So if from point P we draw two tangents to this circle, the first tangent will be this tangent. We define the point of tangency of the first tangent with this circle as point A. Then we will draw also a second tangent from point P to this circle. We will define the point of tangency of tangent, the second tangent with this circle is point B. And according to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So whenever you draw two tangents from a common external point to a circle, then the length of those two tangents will be equal to each other. The length of the first tangent is PA, the length of the second tangent is PB, and according to rule number 8, the lengths of those two tangents are equal to each other. That is to say, PA equals to PB. Okay, so actually we can implement rule number 8 in our drawing, because in our drawing we have the external point E, and from point E we have two tangents to this circle. The first tangent is tangent EN, the second tangent is tangent EK, and according to rule number 8, the lengths of those two tangents that exist from external point to a circle, to this circle, the lengths of those two tangents will be equal to each other. That is to say, NE equals to KE according to rule number 8. According to rule number 8, NE equals to KE. If we define NE as X, that is to say NE equals to X according to our definition, then from this equality we will get that KE also equals to X. KE also equals to X. So we can write here that KE equals to X. In the next step, we will calculate the value of EB. From the drawing, you can see that EB equals to AB minus AN minus NE. Okay, EB equals to AB minus AN minus NE. Okay. You can see from the drawing that EB equals to AB minus AN minus NE. So EB equals to AB is 4 units, AN equals to 1, and NE equals to X according to our definition. So in conclusion, we found out that EB equals to X minus 1, EB equals to 4 units, AB equals to 4 units, here AB equals to 4 units. This is the length of one side of square ABCD, therefore it equals to 4 units. So in conclusion, we found out that EB equals to 4 minus 1 minus X. That is to say 4 minus 1 is 3 minus X. So EB equals to 3 minus X. EB equals to 3 minus X. So we can write here that EB equals to 3 minus X. And we know that BC equals to 4 units because it is one side of square ABCD, therefore it equals to 4 units. So, and we also know that CE equals to square root of 17 plus X units. So, and we know that this angle is a right angle because it is 1 out of 4 angles of square ABCD, and we know that all the angles inside the square are equal to 90 degrees, they are right angles, therefore this angle will be equal to 90 degrees. So we will focus on the right green triangle, triangle CEB, and we will implement the Pythagoras theorem on the right green triangle, triangle CEB. Okay, according to the Pythagoras theorem, in the right triangle, triangle CEB, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right green triangle, triangle CEB, is CE, therefore the square of the hypotenuse is CE squared, and it equals to the sum of the squares of the perpendiculars, that is to say it equals to EB squared plus BC squared. I will repeat again, according to the Pythagoras theorem, in the right green triangle, triangle CBE, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say CE squared equals to EB squared plus BC squared. But we know that CE equals to square root of 17 plus X. CE equals to square root of 17 plus X. And CE squared equals to square root of 17 plus X squared, and it equals to EB squared. EB equals to 3 minus X, therefore EB squared equals to 3 minus X squared plus BC squared. BC equals to 4 units, so BC squared will be equal to 4 squared. 4 squared is 16. So in conclusion, we found out that square root of 17 plus X squared equals to 3 minus x squared plus 16. We will open the brackets on both sides of equation number 2, and we will get that square root of 17 plus x squared equals to 17 plus x squared plus 2 times square root of 17 times x, that equals to 3 minus x squared. 3 minus x squared equals to 9 plus x squared minus 6x plus 16. So here we actually have x squared in both sides of this equation, equation number 2, so x squared will get cancelled. And 16 plus 9 is 25, so I write it down. Here we will get that 25 minus 6x, and on the other side of equation number 2 we will get what is left. It is actually 2 times square root of 17x plus 17. So here we will subtract 17 from this equation, equation number 2, and we will get that 17 minus 17 is 0, plus 2 times square root of 17x equals to 25 minus 17 is 8 minus 6x. So here we will divide this equation, equation number 2 by 2, and we will get that square root of 17, 2 times square root of 17 over 2 is square root of 17x equals to 8 over 2 is 4, and minus 6x over 2 is minus 3x. So actually in conclusion, we got that square root of 17x equals to 4 minus 3x. Here we will add 3x to this equation, equation number 2, and we will get that square root of 17x plus 3x equals to 4. So here we will take a common factor x from, we take out the common factor x out of these two expressions, and we will get that, so x is a common factor. What is left from square root of 17x after we took from it x as a common factor? What is left? It is actually square root of 17. And what is left from 3x after we took from it x as a common factor? What is left? It is actually 3, and it equals to 4. Here we will divide this equation, equation number 2, by square root of 17 plus 3, and we will get that x equals to 4 over square root of 17 plus 3. So we found out the value of x. X equals to 4 over square root of 17 plus 3. Here we will multiply this equation, this side of equation number 2, by square root of 17 minus 3, and then we will divide it by square root of 17 minus 3, and we'll get that x equals to 4 times square root of 17 minus 3 over square root of 17 minus 3 times square root of 17 plus 3 . So here we find out the value of this expression, square root of 17 plus 3 times square root of 17 minus 3, according to the algebraic identity that a plus b, a minus b equals to a square minus b square. So in our specific case, a will be equal to square root of 17 and b will be equal to 3. So actually a minus b plus b, a minus b equals to a square minus b square. So a square is square root of 17 square is 17 minus b square. B is 3, so b square is 9, so it is minus 9. So in the numerator, from this expression, we left only with 17 minus 9 because it is a square minus b square, and a square minus b square is 17 minus 9. And in the numerator, we didn't touch in the numerator, so it remains as it is. It is actually 4 times square root of 17 minus 3 . Seventeen minus 9 is 8, so I write it now. Here 17 minus 9 is 8. I write it now. I repeat again. 17 minus 9 is 8, so I write it down. It equals to x. So in conclusion, we found out that 4 times 17, square root of 17 minus 3 over 8 equals to x. Here we will divide the numerator and the denominator by 4. 4 over 4 is 1, so 4 will get cancelled, and 8 over 4 is 2. So we will get that, according to equation number 2, x equals to square root of 17 minus 3 over 2. We found out the value of x, according to equation number 2, the value of x is square root of 17 minus 3 over 2. So what is left to find out? What is left to find out is to find out the area of the green right triangle, triangle CBE. Actually, the area of any triangle is equal to the base of the triangle times the height to the base over 2. I will repeat again. The area of any triangle is equal to the base of the triangle times the height to the base over 2. This is the sign of area. It means the area of a triangle. So the area of our triangle, again, our triangle CBE, the area of triangle CBE. This is the sign of the area. It means the area of triangle CBE equals to the base of the triangle. The base of triangle CBE is BE or EB times the height. The height to the base is BC. Again, the height to the base is BC. The height must create 90 degrees with the base, and indeed BC creates 90 degrees with the base EB. So it is indeed the height over 2. So we found out that the area of the right green triangle CBE equals to EB times BC over 2. Or the area of the right green triangle CBE, according to equation number 3, equals to EB. The value of EB is 3 minus x. Times BC. BC equals to 4 units over 2. So in conclusion, we found out that the area of the right green triangle CBE equals to 3 minus x times 4 over 2. 4 over 2 is 2, so I'll write it down. So in conclusion, we found out that the area of the right green triangle CBE, according to equation number 3, equals to 2 times 3 minus x. I'll repeat again. We actually found out that the area of the right green triangle CBE, according to equation number 3, equals to 2 times 3 minus x. But we have already found out the value of x. We know that the value of x, according to equation number 2, we have already found out that x equals to square root of 17 minus 3 over 2. Okay? So actually we have the equation number 3 that the area of the green right triangle CBE equals to 2 times 3 minus x. So here we will place the value of x from equation number 2 in x from equation number 3. Okay? Again, we will place the value of x from this equation number 2, in x from equation number 3. Here. And we will get that the area of the green right triangle CBE, according to equation number 3, will be equal to 2 times 3 minus x. X is actually square root of 17 minus 3 over 2. Okay, here replace the value of x. Here, value of x from equation number 2, replace it in x from equation number 3, and we got this expression. This is actually x. So here we will multiply 3, this 3 by 2, and then we will divide it by 2, we will multiply it by 2, and then we will divide it by 2 in order to have a common factor with this expression, and we will get that the area of triangle CBE, according to equation number 3, will be equal to 2 times 6 minus square root of 17 minus 3 over 2. Okay, we got this expression. Here 2 over 2 is 1, so 2 will get cancelled. And what is left after we cancel 2? For equation number 3, what is left? It is actually we got that the area of the green right triangle CB equals to 6 minus square root of 17 minus 3. Okay, we found out actually that the area of the green right triangle CBE according to equation number 3 equals to 6 minus square root of 17 minus 3. We will open the brackets in this side of equation number 3, and we will get that the area of the green right triangle CBE according to equation number 3 equals to 6 minus square root of 17. Here we have minus 3 is plus 3. So we actually found out that the area of the green right triangle CBE according to equation number 3 equals to 6 plus 3 is 9 minus square root of 17 square units. Or in terms of numbers, it equals to 4.88 square units. I will repeat again. We actually found out that the area of the green right triangle CBE equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of the green right triangle CBE equals to 4.88 square units. I will repeat again. The area the area of this green right triangle CBE equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of this green right triangle CBE equals to 4.88 square units. Now I'll summarize the lecture. Actually, we wanted to find out the area of this green triangle. We have here square ABCD. One side of square ABCD equals to 4 units. Inside this square, we have this circle. The radius of this circle equals to 1 unit. And we want to find out the area of this green circle. So, first of all, I presented to you a new rule, rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and we have tangent AB is tangent to this circle at point M. Point M is the point of tangency of tangent AB with this circle. And we have this radius, the radius OM, it is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, according to rule number 1, the tangent AB will be perpendicular to this radius. That is to say, this circle equals to 90 degrees and this circle also equals to 90 degrees. So whenever you have a radius, like in this drawing, that is drawn to the point of tendency, then the tangent will be perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. We implemented rule number 1 in our drawing. In our drawing we have this radius that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent DA with this circle. Therefore, the tangent DA will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle also will be equal to 90 degrees. We also know that all 4 angles inside the square are right angles. Therefore, this is a right angle. So here, this angle equals to 90 degrees. And we have here this radius, it is drawn to the point of tendency. Therefore, the tangent AB will be perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Then we have also this radius that is drawn to the point of tendency. Therefore, tangent CE will be perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Then I presented to you rule number 2. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. And if we focus on quadrilateral MOAN, then according to rule number 2, the sum of its angles is equal to 360 degrees. So which angle we have inside quadrilateral MOAN? We have 3 right angles, 1, 2, 3. And the sum of 3 right angles is 270 degrees, plus the size of this angle that we define, this angle x, must be equal to 360 degrees according to rule number 2. 270 degrees, that is the sum of 3 angles, plus the size of the 4th angle must be equal to 360 degrees according to rule number 2. Then I presented to you rule number 3, and actually we subtracted 270 degrees from this equality and we got that angle x equals to 90 degrees. So we actually found out that all 4 angles inside quadrilateral MOAN are right angles. They are all equal to 90 degrees, and we have also rule number 3 that if a quadrilateral has 4 right angles, then it must be at least a rectangle, if not a square. And because of the fact that quadrilateral MOAN has 4 right angles, it must be a rectangle, if not a square. So we will relate to quadrilateral MOAN as a rectangle. We will relate to quadrilateral MAON as a rectangle. We have also rule number 4 that states that the opposite sides of a rectangle are equal to each other. So in rectangle MOAN, according to rule number 4, its opposite sides are equal to each other. That is to say, MO equals to AN. According to rule number 4. MO equals to AN according to rule number 4. But it is given us in the question that MO equals to 1 unit. So we can write here that MO equals to 1 unit. From this equality we will get that AN also equals to 1 unit. Okay, AN also equals to 1 unit. Likewise, according to rule number 4, MA equals to ON. MA equals to ON. But we already found out that ON equals to 1 unit. ON equals to 1 unit. So from this equality, we will get that AM also equals to 1 unit. So we found out that AM also equals to 1 unit. Actually, we found out that all four sides of quadrilateral MOAN are equal to each other, and they are all equal to 1 unit. And we also found out that all four angles inside a quadrilateral MOAN are right angles. I presented to you rule number 5. According to rule number 5, if a quadrilateral has 4 right angles and 4 equal sides, then it is a square. And because of the fact that quadrilateral MOAN has 4 right angles and 4 equal sides, therefore it is a square. Quadrilateral MOAN is a square according to rule number 5. Okay, so we relate to quadrilateral MOAN as a square, and we also have rule number 6. According to rule number 6, the diagonals of a square bisects the angle of the square into 45 degrees angles. So we relate to square MOAN, this square. According to rule number 6, the diagonal OA bisects this angle into 2 angles that each of them is equal to 45 degrees. That is to say, this angle equals to 45 degrees and this angle also equals to 45 degrees. What is this angle? This angle is angle OAB. So according to rule number 6, angle OAB equals to 45 degrees. Likewise, if we relate to the big square ABCD, then according to rule number 6, the diagonal CA bisects this angle into 2 angles that each of them is equal to 45 degrees. That is to say, angle CAB equals to 45 degrees according to rule number 6. Angle CAB equals to 45 degrees according to rule number 6. So angle OAB and angle CAB they are both equal to 45 degrees, therefore they are equal to each other. That is to say, angle CAB equals to angle OAB, and because of the fact that angle CAB equals to angle OAB, we will conclude that the diagonal CA of square ABCD passes through point O. It must pass through point O, otherwise, if diagonal CA doesn't pass through point O, then angle CAB will never be equal to angle OAB. But because of the fact that those two angles are equal to each other, we will conclude that the diagonal CA passes through point O. Okay, then I presented to you a new rule number 8. According to rule number 8, the lengths of two tangents, actually it is rule number 7. Rule number 7 states that the length of a diagonal of a square is equal to square root of 2 multiplied by the length of the square's sides. So what is the meaning of rule number 7? The meaning of rule number 7 is that if we have this square ABCD, and we know that the length of one side of square ABCD is equal to S units, therefore all the other sides are also equal to S units. If the length of one side of square ABCD equals to S units, then the length of its diagonals will be equal to S times square root of 2 units. This is according to rule number 7. We implemented rule number 7 in our drawing. We related to the small square MON. We found out the value of diagonal OA. The value of diagonal OA equals to the length of square MOAN side, that is 1 unit, times square root of 2. So we found out that the length of diagonal OA equals to square root of 2 units. Likewise, we related to the big square ABCD. According to rule number 7, the length of diagonal CA of square ABCD will be equal to the length of square ABCD side, that is actually 4 units, times square root of 2. So we found out that CA, the diagonal CA of square ABCD, equals to 4 times square root of 2 units, because it is the length of one side that is 4 times square root of 2 units. This is according to rule number 7. Then we calculated the value of CO, the length of CO. From the drawing you can see that CO equals to CA minus OA. Again, CA minus OA equals to CO. CO equals to CA minus OA, but we have already found out that CA equals to 4 times square root of 2 units and AO equals to square root of 2 units. So CO equals to 4 times square root of 2 units minus 1 times square root of 2 units. That is to say, CO equals to 3 times square root of 2 units. So we actually found out that CO equals to 3 times square root of 2 units. Okay, then we focus on the right green triangle, triangle COK. On the right green triangle, triangle COK, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is CO, therefore the square of the hypotenuse is CO square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OK square plus CK square. We have already found out that CO equals to 3 times square root of 2 units, so CO square will be equal to 3 times square root of 2 square plus OK square. OK equals to 1, so OK square is 1 square is 1, and CK square is CK square. 3 times square root of 2 square is 9 times 2. 9 times 2 equals to 1 plus CK square. 9 times 2 is 18, so 18 equals to 1 plus CK square. We subtracted 1 from this equation number 1. 18 minus 1 is 17, so in conclusion we found out that 17 equals to CK square. We took a root out of this equation number 1, and we got that CK equals to square root of 17 units. So we found out that this line segment CK equals to square root of 17 units. Then I presented to you rule number 8. According to rule number 8, the lengths of two tangents from a common external point to a circle are equal. What is the meaning of rule number 8? The meaning of rule number 8 is that if we have this circle and an external point P of this circle, and from the external point P we draw two tangents to this circle, then the lengths of those two tangents will be equal to each other. That is to say, PA will be equal to PB. So whenever you draw two tangents from an external point of the circle to that circle, then the lengths of those two tangents will be equal to each other according to rule number 8. We implemented rule number 8 in our drawing. In our drawing we have the external point E, and from this external point E we have two tangents to this circle, tangent EN and tangent EK, and according to rule number 8 they are equal to each other. That is to say, NE equals to EK. According to rule number 8, we defined NE as X. So according to this equality, we will get that EK also, OKE also equals to X. So NE equals to X and EK also equals to X. Then we found out the value the size of line segment to the left of line segment EB. The left of line segment EB equals to AB minus AN minus NE. EB equals to AB minus AN minus NE. So AB equals to 4 units, AN equals to 1 unit, and NE equals to X according to our definition. So in conclusion, we found out that EB equals to 4 minus 1 minus X. 4 minus 1 is 3, so EB equals to 3 minus X. So we found out that EB equals to 3 minus X, CB is equal to 4 units, and CE equals to square root of 17 plus X. And we know that the green triangle is a right triangle because this angle is one out of 4 angles of square ABCD, and we know that all 4 angles inside the square are right angles, therefore it is a right angle. We implemented the Pythagoras theorem in the right green triangle CBE, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars in the right triangle CBE. The hypotenuse in the right triangle CBE is CE, so the square of the hypotenuse is CE square, and it equals to EB square plus BC square. CE equals to square root of 17 plus X, so CE square will be equal to square root of 17 plus X square, and it equals to EB square. EB equals to 3 minus X, so EB square will be equal to 3 minus X square plus BC square. BC equals to 4, so BC square is 4 square. 4 square is 16. Then we open the brackets on both sides of this equation number 2. Square root of 17 plus X square equals to 17 plus X square plus 2 times square root of 17X. And 3 minus X square equals to 9 plus X square minus 6X plus 16. Here we have X square on both sides of equation number 2, so X square will get cancelled. And then we know also that 9 plus 16 is 25. So here we subtracted 17 from this equation number 2, and we got here 17 minus 17 is 0, so what is left here is only 2 times square root of 17x, and 25 minus 17 is 8. Here we have minus 6x. So in conclusion, we found out that 2 times square root of 17x equals to 8 minus x. We divided this equality, equation number 2, by 2. Here 2 over 2 is 1, and 8 over 2 is 4, and minus 6x over 2 is minus 3x. So in conclusion, we actually found out that square root of 17x minus 4, square root of 17x equals to 4 minus 3x. Here we added 3x to this equation number 2, and we got the square root of 17x plus 3x equals to 4. Here we took a common factor x out of these expressions, and we got that x times square root of 17 plus 3 equals to 4. Here we divided this equation number 2 by square root of 17 plus 3, and we got that x equals to 4 over square root of 17 plus 3. Here we multiplied this side of equation number 2 by square root of 17 minus 3, and then we divided it by square root of 17 minus 3. We got this expression, and here we have square root of 17 plus 3 times square root of 17 minus 3. We will find the value of this expression according to the algebraic identity that states that a minus b times a plus b equals to a squared minus b squared. Here a equals to square root of 17 and b equals to 3. So a square is square root of 17 square, it equals to 17, and b square is 3 squares. 3 square is 9. So in conclusion, we found out that this expression equals to 17 minus 9. Okay? So in the denominator we have 17 minus 9, and in the numerator is left. What is left is what is there is what is left, because we didn't touch on the numerator. So in conclusion, we found out that 4 times square root of 17 minus 3 equals to 4 times square root of 17 minus 3 over 17 minus 9 equals to x. 17 minus 9 is 8, so we got that 4 times square root of 17 minus 3 over 8 equals to x. We already so x equals to square root of 17 minus 3 over 2. Okay, here actually we divided the numerator and the denominator by 4. 4 over 4 is 1, so 4 will get cancelled, and we left only with square root of 17 minus 3, and 8 over 4 is 2. So in conclusion, we found out that x equals to square root of 17 minus 3 over 2. According to equation number 2. And the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of the green right triangle, triangle CBE, will be equal to the base of the triangle that is BE. The base of the triangle is BE times the height is BC over 2. So the area of triangle CBE, the right green triangle, triangle CBE equals to EB times BC over 2. We have already found out that EB equals to 3 minus x and BC equals to 4 units. So the area of the green right triangle, triangle CBE equals to 3 minus x times 4 over 2. 4 over 2 is 2. So in conclusion, we found out that the area of the green right triangle, triangle CBE equals to 2 times 3 minus x. And we have already found out the value of x. Actually, the value of x is square root of 17 minus 3 over 2. And according to equation number 3, the area of the green right triangle, triangle CB equals to 2 times 3 minus x. So we replace the value of x from equation number 2 in this x from equation number 3. So we did it, and we found out that the area of the green right triangle, triangle CB equals to 2 times 3 minus, and this is actually x. We place the value of x inside x, and we got this expression. Here we multiplied 3 by 2, and then we divided by 2 in order to have a common factor with this expression, and we got that the area of the green right triangle, triangle CB equals to 2 times 6 minus square root of 17 minus 3 over 2. 2 over 2 is 1, so 2 will get cancelled. And in conclusion, we found out that the area of the green right triangle, triangle CBE equals to 6 minus square root of 17 minus 3. We opened the brackets on this side of equation number 3, and we got that the area of the green right triangle, triangle CBE equals to 6 minus square root of 17 plus 3. Here 6 plus 3 is 9. So in conclusion, we got that the area of the green right triangle, triangle CBE equals to 9, equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of the green right triangle, triangle CBE equals to 4.88 square units. I will repeat again. The area of this green right triangle, triangle CBE equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of this green right triangle, triangle CBE equals to 4.88 square units. Okay, thank you very much.